Very good afternoon, friends. It's my pleasure to introduce Mr. Ramu. He has a very strong technical mind. He is an astute professional with 38 years of experience in aluminum casting field. He is currently heading the operations at Alphacraft as vice president for the past few years. He has a vast experience in aluminum metallurgy and die design, a rich experience in production of intricate automotive parts like cylinder heads, car wheels, inlet manifold, and compressor housing for turbocharger, and intricate casting for aerospace applications. He has set up multiple fully automated casting and machining facilities. He has got his trainings in abroad as well. He was trained in South Korea to master advanced tilting gravity casting, die casting technology. He has visited as a consultant to Middle East and offering consultancy to ornamental casting techniques and audit of alloy making plants. He has presented various papers in multiple events. Also a certified Six Sigma champion. His academic credentials: he was a mechanical with mechanical engineering and metallurgy as his elective, and I also privileged to work with him in some of the projects. Sir, the stage is yours, sir. Please. Thank you.
Thanks for the opportunity given to me now to present. Actually, this topic was given by Mr. Prabhakar. Actually, it's need of the day and very essential, and thanks, Prabhakar. The title is Smart Approach for Increasing Productivity, Energy Saving and Cost Reduction in the GDC Process. So I have not given any arithmetic calculation or the numbers here. Just I have outlined the proposal. So what are the machineries to be used or that will support to increase the productivity, and methodology and benefits, and again, so how it is going to help for the lower carbon footprint. See, these are the essential measures to enhance productivity and save energy. So to start with optimizing the chemistry of the raw material. So again, I think in the morning session we heard a lot about raw material cost and how to control over that. So we can do a little bit on controlling the alloy cost. Hope the Balu or whoever alloy makers come here will agree to that. So instead of demanding 0.1 iron or 0.2 iron unnecessarily, so we can work with additional 0.1 or 0.2 iron content. That will make a big difference in cost, because minimum we can reduce or 2 or 3 rupees or 4 rupees, sometimes depends upon the alloy. So if the casting do not require any leak testing or load bearing strength, we can easily choose and customize the alloy. We can even convince our customers, as long as they get what they want, like properties or leak proof, then we can easily do that and then enjoy the benefit out of that. And second is induction furnace, immersion heater, molten metal transfer, and we are going to touch these on the next coming slides. Hollow core making, tilt gravity. So first we should think to eliminate the diesel fired or oil fired furnaces from the foundry, because personally I am using it for more than 30 years or 28 years induction furnace, but considering all issues, we should, okay, initial cost will be little higher, but the long-term benefit, and there are many benefits when we use induction furnace. Efficient, clean, safe, eco-friendly, and we can easily get it adopted for Industry 4.0. We will get a very clean metal with less oxidation. So one of the biggest problem for many defects are the unclean metal or the quality of the metal. So the quality of the metal contributes around 70 or 80% of the defects. So here when we use the induction furnace, we will have an accurate temperature control, and even when we use an tower melting furnace or any other furnace, it's very difficult to change alloy, or we'll have to have a furnace for each grades, or otherwise for aluminum silicon one furnace, and then for aluminum silicon copper we'll be forced to use another furnace, because we cannot remove the entire metal from the tower melting furnace or any other furnace. Whereas here it is very easy to remove the entire metal. We can tilt and then clean, and then we can charge whatever the grade we want. So the contamination will be very less. And again, if you compare the cost, diesel or furnace oil or any other LDO, then the cost will be less when you use induction furnace. No gas, you can have a foundry very clean, and it's very user friendly. One of the biggest advantages, even we can operate, even if the furnace, if the kilowatt is around 250 or 350, we can operate at even 10% of the power. When we don't want to tap or increase the temperature, if we have to hold it for some times due to some reasons, we can easily bring down the power and then operate it. And it's very quiet and low vibrations, and space saving, and no flames, and again low carbon footprint which is required. And in Alphacraft, in our company, we have installed 4 induction furnaces, and the total of 2000 kgs per hour capacity. Another one is after melting, then we have to hold the metal. We use either again diesel fired furnace or electric resistance heating furnaces, and if we have to hold 500 kg of molten metal, then we are forced to use 48 kV, 48 kilowatts heaters or coils around the crucible, and there is a crucible that will be around 300 kg or 250 kgs. So we will be spending energy in all those things, and we won't be able to cut down the cost or whatever the way you want. We tried with the immersion heater. The picture what you see on right hand side is the furnace that's built by us, and we imported a immersion heater from Denmark. We are trying to source locally. If someone can help us, then it would be great. So we use this immersion heater, but of course we developed only one number, and we have got 18 furnaces, and we'll have to slowly replace it all by this, and energy efficiency is quite high. For 500 kg, we require only 12 kilowatt, because there is no crucible, and we are putting the element or the heating element directly inside the molten metal. So the energy loss is very minimal here. So in each slide, I have addressed this productivity and cost saving and then energy saving. And again, for a mass production and achieve a productivity, we should try to use the forklift, which is very again cost effective, and you can save a lot, and you can move from one station to other stations without much hassle. You can directly tap molten metal into the ladle and then move to your pouring stations. And only one person is required for that. We don't need to deploy 2 people to transfer the molten metal from melting to holding, because you can have a tilting arrangement in the forklift itself. And again, for a continuous operations, you can build the furnace with the wheels, and you have to have 2 furnaces in case if you don't want any interruption during productions. I think this furnace was again built by Praveen by his father, and we deployed it in a carousel auto pouring line, and you can move it even by hand or with a motorized one. So the production will not get affected at all. So because nowadays we stopped doing all the treatment in the holding furnaces. We treat the metal in the transfer ladle itself and then transfer the treated metal to the holding furnaces. But in case if you are forced to do the treatment in the holding furnace, then you can have this arrangement, and this will help a lot. Again, when it comes to casting, so whoever is using a standalone, we can go for a tilting gravity die casting process. There are many machines available in the market. We can choose accordingly. So don't need to buy a bigger machine and ending up incurring a huge power. We can choose according to the mold weight and the casting weight. See the advantage over tilting gravity die casting process. So improved metal flow, reduces turbulence and defects, and improved casting quality, less porosities, better finish, higher yield when compared to standalone, and longer die life due to controlled filling, and automation friendly, and the industry. We can easily connect to IoT. And these are the castings on the top of it. You must have seen this, some of you may have seen in the exhibitions. The top or 3 rows are all made out of tilting gravity die castings. I think the picture is not clear because it's short and long. So 1.2 meter long, and casting weighing from 4 kgs to 12 kgs. The latest one that we are developing for 16 kgs, all being produced by a tilt gravity die casting. So we can enjoy the quality. So another for a mass production, we'll have to play a video. So we can go for a gantry operation. It's a very low cost automation, and later then we move to a fully CNC controlled gantry auto pour systems. We started with that and then moved to other systems. So the 4 machines, each machine can accommodate, depends upon the size of the castings, 2 cavities or 3 cavities. So and we can transfer, whoever presses the metal, the button, the ladle will move to that stations. So the 4 machines can be operated by 2 people here in this gantry auto system. This is the first machine. Then what the second and third and fourth? Now we have got a 4 gantry system. We have got a fully automated CNC control. So even we can accurately control the weight, acceleration, and the weight can be varied. Even the station 1, we can pour X weight, and for station 2, we can choose any weight we want. So he is producing inlet manifold. Yeah. By having this setup, we can reduce the manpower requirement. And by having this arrangement, another thing is we can have a common power pack. We don't need to have an individual power pack for each machines. What we have done for the second and third and fourth machines, we designed a common power pack with 2 hydraulic motors and pump. So the energy saving again is very significant. Yes. Next. This is the latest gantry auto pour system with again 2 furnaces in the middle and 4 TGDC machines on either side. And here you can vary the weight of the metal as we like. And even we can handle 2 grades of metal in this same line. Suppose if we need for example, 1 grade like a AC4B for first 2 machines, and you can have that AC4B in the first furnace, and if you want something else like a LM6 for the other 2 machines, you can fill the LM6 in the second furnace, and the whole gantry movement can be programmed, and the weight is also controllable here. So now we have got 3 machines like this, and we are operating 12 TGDC machines with the multiple cavities. So here the productivity is very high and non-stop productions. So when the productivity goes up, automatically the cost comes down, the energy comes down, that's the one. And for all the 4 machines, you can see at the top, there's only 1 power pack. Earlier or even now, many places, they used to have a power pack for each machines. For example, for the size of the machine, that what we have is a 2 meter wide, and which can handle around 3 or 3.5 tons of die, but each requires around 20 or 25 HP. But what we have done, we have designed only 1, but with a 2 motor and 2 pumps. So the maximum demand, when we avail high tension power, we'll have to pay around 560 or 580 rupees per kVA. So if we consider 3, so 12 machines, in traditional way we'll have to have a 240 kVA, 240 kVA, but here we are managing with the 60 kVA. So 180 kVA maximum demand charge is directly saved, and energy consumption for each machine has also come down significantly. So another method for mass production, the carousel. I think it's quite difficult, I think, to stay focused after lunch, I believe, but I'll try my level best to keep you engaged, because I can see all of your face, and it's not easy, I accept, but Prabhakar has given me only this slot.
Actually, as per request,
yeah, because I had to come from Compt. I started early in the morning. So there are 8 cavities, 4 stations and 8 cavities. So we need actually only 1 operator, because he has to place the core. Once he places the core and he can press a button, it will go to the next station for a pouring. Is the initial stage done in my previous company, and 2 castings can be poured at a time with a tool cup. The initial stage, then we replace this cup by ceramic cup. We are buying from Prabhakar is supplying a cup for that. It's a stainless steel, but still the metal is sticking on the wall. After replaced by a ceramic, no, it's a non-wetting type, so no issues. It's ideal for a mass production, ideal for we can produce around, when you, I can say that, yeah, 2 cavity dies, 4 dies, we are producing around 1500 to 1600 numbers in a day. So we need only 3 people. We can, no. Because I am testing their patients, so they are waiting for the machines to rotate. So if the laptop is here, then I can scroll it. So one side the pouring is happening, another side casting extraction. The timing is programmed. This station is just behind exactly behind the pouring station. I think laptop, you are not. I should operate. So, no, show it. Okay. Now, die got open. This is the casting extractor. It is picking 2 castings from the mold. And this is the conveyor, cooling conveyor. There is a mist spray inside that, and it drops it in the conveyor. When it reaches the other end, the casting becomes maybe around 40 or 50 degree temperature, and then operator can take it up for the next operation for knockout or highly recommended for the next for the mass productions. So when we say the productivity, so we should start developing a multi-cavity dies. Even if our customer doesn't pay, then we'll have to invest on the tooling and then see that we are developing a multi-cavity core box or the casting die. Because that will fetch a lot, that will help a lot to cut down the cost and increase the productivity. So the investment on initial tooling won't be much when compared to the loss or the additional cost that we are going to incur during the production for throughout the program life. So we have seen the casting now. the post casting. After casting, again we have to have a, wherever possible we should go for an automation. Again in Alphacraft we developed a carousel table with a robot, and the castings are quite here. It's a very complex shape with having multiple risers, runners. So we designed this system, and we are using it for cutting runner riser and deburring and finishing it wherever. Some areas we have to use some kind of an emery wheel or a polishing wheel. So this is the on the top. And your top, this is the cell. There is a robot inside, and these two are carousel table. And there are 8 tools are there, various cutter, circular saw, bar cutter, whatever you want you can store it. The robot will pick from there and then do whatever the operations we want. So why we have gone for 2 table? Because the loading time is not there here in this system. So operator can load all 6 components in one table. By the time it completes, then it can come here and then do the whatever the operations we have prepared. So that's the beauty of this system. Again, for our productivity, in each slide we have addressed productivity, energy saving, and yeah. It's again it's a 5-axis runner and riser cutting machines. Normally we use 5-axis machine or costly machines only for machining, but we should think about using it for foundry cutting and all. It will give a lot of benefits. Yeah, next. Again, we tried out a new thing that to save energy. Now the most important is the energy in the foundry. So what we did, we developed a mold, a casting mold with a shell core box in middle. So you can see at the picture at the top, to your left and right is the casting. It's again a tilting gravity die casting process. In the middle, at the same insert, we created a shell core mold impressions. So idea behind is to make use of, because we can see that lot of heat that the mold emits during the solidification. It's being wasted now. We are not able to utilize it. So what we did, we created this core in the middle, and we make use of that waste or energy that comes from that to produce this cores. So nowadays what we do, we are using these type of heaters. We are inserting in the core box. Depends upon the core box size, we need minimum 8 or 10 heaters per side, and totally we need 16 kilowatts for producing the shell core. So in this way that we can eliminate these heaters, so we directly save the energy, and not only the energy cost, and the same operator, whoever is producing the casting, will be forced to produce core also. So we tried one model, and the same TGDC machines to be used for, we have to have an arrangement for sand core blowing, And the same with an attachment, you can produce core also. So the manpower cost, energy cost, and footprint, the space saving. When you have an integrated machine, you can save a space also, which is very, very important and very costly. Yeah, so by eliminating the fuel-fired furnace and proper layout and automation, so we can keep the foundry very clean, even better than machine shop. So foundry should not be treated like a kitchen, or not latest is involved kitchen. So we have to have a very clean environment. I think Prabhakar was mentioning when he was in the session. So we have to create a very clean environment. We should make the people to love the place they work. This again, the Alphacraft. And layout also very, very important. The material handling, the distance should be as minimum as possible. Then we will get the efficiency. So this is the induction furnace. This is the melting furnace. And then there is a casting cell, again a gantry. At the end, after cooling, it goes to the core knockout machine, and I think other pictures is not here. After core knock, there will be a runner riser cutting machines, and then on this side opposite to this, behind this, there are fettling machines, and then behind that, BMC, the CNC machining center. So the raw material flows from here. When you say raw material, it's an ingot, and it takes only one U-turn and comes out as a FG. Again, I think same for clean. Yeah, how we have to maintain the shop floor. Next. And again, it is the GDC facilities, Alphacraft GDC facilities, where we have deployed all these auto pour and robots and everything. So one more new high pressure die casting plant is getting ready. It will become operational in another 2 weeks, where we are going for a fully IoT, and it's going to be a digital smart factory. It will be around 500 meters from this same road in Coimbatore. Yeah. That's all. So I am open for. I don't know how many of you suffered or how many of you heard, or but though I made it very short. Even I went out and then I removed some of the slides and numbers, because unless otherwise we saw something, like a movie or something. I added just 1 hour or 2 hours back because now I am okay for, or I welcome any questions from you.
For this nice presentation.
Thank you, sir.
Sir, what is the ratio of energy compared to the electrical furnace or gas furnace to the induction furnace? And what is the investment part? How much investment we have to do for induction furnace compared to the electrical furnace or gas furnace?
So earlier the investment required for induction furnace was very high. Now the lot of players have come in India, and it will in par with any gas-fired furnace, or sometimes even less than that. Again, that depends upon what is the capacity you need. Here the flexibility is more. Even if you want 100 kg induction furnace, it is available. Even if you need only 50 kg, even we are going for 50 kg capacity induction furnace for trial and proving. So we don't need to switch on 500 kg and then waste energy. So that's flexibility is available. And the good tower melting furnace of 500 kg and induction furnace 500 kg, definitely will be the same, or sometimes if you import, then the from Strike-on-Dal, the tower melting furnace cost is more than induction furnace. And the energy, it's within our control. You cannot control the burners accurately. Suppose if you want to hold a metal at 10% of the energy, it is in no way possible. I have seen, I'm the one who takes the reading every day and then see the cost of melting every day. And one more thing, to sustain the cost or to reduce the cost, you have to monitor the cost on daily basis, at least on some areas like melting, holding, core making, etc. in a foundry. So then we will be able to understand whether it's being wasted or it's on par with our norms or it matches the norms. Yeah, so when you say in induction, I think you can control within 0.8 or 0.85 units per kg of melting. And again, it's not only for just melting it, but in a month, in a year, what is the energy that we are going to spend for getting that molten metal, and what is the diesel or the energy that we spent is more important. You have to compare that. If you are going to have an induction furnace now, you have to have that history, how much diesel or gas that you spent previously, and then come. Yeah.
Yeah, I have seen earlier Alphacraft for using the reverberatory and Skelner and furnaces. Now, with this new induction, how could you could able to maintain that alloying?
Yeah, that's
because
why. Yeah, please,
you will be keep on changing that alloying, right? I mean, because being into GDC, there will be different types of alloy will be used. Because with the lining in induction, how we could be able to achieve the alloying?
First of all, we don't mix PDC alloy and GDC, because the PDC alloy, the behavior or the characters is totally different, and it's more of a secondary grade aluminium. But even the plant is different now. We have separated a GDC plant and then PDC. So both are being now manufactured in two different plants, and it's very easy. There are a lot of advantages over there, because the approach for GDC is entirely different from the PDC. And again, for a high pressure die casting, you can have any crucible. It doesn't make, because there is no aluminum silicon alloy alone there. Always there will be aluminum silicon copper combination, but rarely there are nowadays some alloys have come like a silicon and all. It requires only aluminum silicon. There is no copper there, or sometimes silicon is, in some other case silicon is very less. So here the advantage over induction furnace, you can empty it, you can tilt it, you can empty it. In case if you are so particular about the contamination, you can just melt 50 kg. In case if it is a 500 kg shell, you just charge 50 kg of whatever the metal you want to suppose to pour, melt, wash it, and then take it out. And it can be done very quickly. So that's the beauty of this. But you don't need to do that. In case if you are so particular about the contamination, we can still do that. But so far I have not come across that type of a situation. I have done it only for when we produce the aerospace component.
Integrated casting.
Yeah.
How you are adjusting that cycle time between the core making process and casting?
Because the core making requires very less when compared to, because in any normal casting requires around, solidification time is the matter, because the tilting is only 8 seconds, tilt back is another 8 seconds. So curing, solidification of the casting is around 2 minutes or 100 seconds, but we can produce core within, the core doesn't require so much curing time. So the core production time is very less. So what we enjoy here is when you tilt, it's same required for a core, and then we are getting it blown, and because there is no any separate energy that we are giving to the core box. The energy comes from the mold, so we can afford to spend little extra time, because for me it comes free of cost of energy and manpower.
The wonderful presentation, and you are sharing your practical experience to us. And further questions can be discussed offline because of the time constraint. We can discuss offline.
I can
Mr. Ramu,
understand
sir.
that it will take some more time.
Thank you,
for
sir.
them
Thank
to-
you. Now I invite Mr. past chairman of Chennai chapter, Mr. Ranganathan, to facilitate Mr. Ramu, sir.